A Boolean expression is used when you want your outcome to be a true or false condition by using a Boolean operator. The and or Boolean operators enable expressions to have more complicated structures called compound expressions or compound query. These compound expressions are used to compare multiple conditions. The following are Boolean expressions. And. Both expressions must be true in order for the record to be selected. It's used to limit or reduce the number of records selected. You would use the AND operator when using multiple attribute fields as the selection criteria. So here we have an OR Boolean operator. One or the other of the two expressions must be true in order for the record to be selected. This expression is used to expand the number of records selected. It is an inclusive operator because either of the two conditions may be true to select a record. You would use an OR operator when using a single attribute field. Okay, so let's talk about the NOT operator for a second. You would use a NOT operator at the beginning of an expression to find features or records that don't match the specified expression. This condition must be false for a record to be selected. So if you remember from the previous video, this can be used in place of that not equal to simple query operator. We'll talk about it a little bit more in an upcoming slide as well. Okay, so there's also a couple of different ORs. So we have our inclusive OR and our exclusive OR. So an inclusive OR can be translated to this, that, or both, and an exclusive OR means this or that, but not both. And so we also need to touch on that order matters. So if we structure our SQL as or A and B or C, it's not the same as A and B or C. You know, this is just the example of those of an or and an and so it's just really important to make sure that we're putting everything into our SQL in the right order with the correct operators. Otherwise, it's not going to select the attribute that you're looking for. So when we have that select by attribute SQL window open, and we have our whole expression in, one way that we can know whether it's going to work or not is we could ask this function to verify our expression for us by using this button here. So I just wanted to highlight that really quickly before we get into this slide. Okay, so here we have an example of a Boolean expression using the OR operator. So again, when we use that OR operator, we're only going to be looking at one field. So an OR operator separates the two conditions. We were looking at a county layer for the state of California. If I wanted to make a selection of just Humboldt County and San Luis Obispo County, I would use this expression here. Okay. So the GIS software the GIS software would check the presence of either the attribute Humboldt or the attribute San Luis Obispo within the name field. Okay, so if we just look at this a little bit more closely, we are comparing two different attributes within the same field. So we have that name field here, and we can see that there's the double quotes. Okay, so it's everything within that field. And then we have equal to, we have that simple comparison operator. And then we have the attribute value, which is Humboldt. And then we have that Boolean operator OR, and so we have that name field, our equal operator, and San Luis Obispo as the attribute. And you can see that the Humboldt and the San Luis Obispo attributes are in those single quotes, so it's selecting just that attribute out of the name field. Something else that I want to touch on is that when you're using a Boolean operator and you're separating different expressions, especially if you want to select two different attribute fields, you have to write that whole series out. So you wouldn't be able to just put a comma in Humboldt and then select San Luis Obispo. You have to actually state the whole thing again for it to be recognized. Okay, so as we can see here over in the data view and then also in the attribute table, so once we have told the select by attributes SQL that we want to just select anything with the name Humboldt and San Luis Obispo, it then does that for us. So here we have Humboldt County and San Luis Obispo County selected. Okay, so here we have an example of an AND Boolean expression. So remember, the AND Boolean expressions are going to allow us to compare and search multiple fields. Okay, so again, here we have an example of an AND Boolean expression. Here we have a layer of parcels, and I want to know which parcels have an improvement field value of 0 and a land field value greater than 0 and a land field value less than 10,000 and an acres field value of greater than 2. The GIS software will check each record for the improvement, land, and acre fields for these conditions. The record will only be selected if all these conditions are true. Okay, so if we take a look at this Boolean operator here, we have the improve field selected, which is going to be equal to 0. We have our AND Boolean operator, and so then now we have the land field selected, so anything that is greater than 0, and then we have a second AND Boolean operator, and we're looking again at the land field and anything that is going to be less than 10,000. And finally, we have our third AND Boolean operator, and we have selected the acres field, and we want anything that is going to be greater than 2. Okay, and so we can see that after we have put all of this in, it has selected the one, or, you know, it looks like here that there are 11 parcels that are selected under this criteria, and we could see some of them showing up in our data view here. Okay. So here we have an example of a not Boolean expression. You're basically expressing that you want everything but that specific attribute to be selected. So here it looks a little bit different than the OR and the AND Boolean operators. So as I discussed a little bit earlier, the not is going to be in front of your SQL expression, and so it can be most likely it's going to be a simple comparison, but it might be compound, and you can also use Boolean operators within that bracket. But just for the sake of this example, we want everything to be selected other than Humboldt County. So we're telling it to not select Humboldt County. So we have our not Boolean operator, and then within the brackets we have the name field selected, the equal comparison operator, and then we have Humboldt is the attribute or the county that we don't want to be selected. So then we can see here all the other counties are selected other than Humboldt. And again, you don't necessarily have to use a Boolean operator to do this. You can just use the comparison operator not equal to. It just kind of depends on what you need. Okay, so though data sets are made up of a uniform collection of entities and feature types, they can still have relationships with other data sets made up of different types of entities, different feature types, or even with non-spatial database tables. When using GIS software, relationships between database tables are typically established using either table relationships or spatial relationships. A table relationship occurs between two or more tables with a common attribute field. A spatial relationship occurs between one or more features on a map based on their locations relative to each other. And so another way to look at it, a table relationship, you're using joins and relates, where a spatial relationship, you might be using like a location selection, which you are probably familiar with by now by some of the activities that we've done where we've selected things spatially or select by location. Establishing a table relationship requires a common attribute field referred to as a key. A key is an attribute that exists in two or more tables and is used to associate them together. For example, you might get presidential election results from a website as a simple Excel spreadsheet that contains a field with the names of counties across the US and other fields of the vote tallies for each candidate. You could then establish a relationship with any other database table that also has an attribute field of county names. If you establish a relationship between one table and another, you have to be sure that the attribute type is the same. So a text field could be associated with another text field, but not to a number field or a date field. Also, the attribute that is establishing the relationship must be precisely the same. For example, if the parcel ID numbers were off, a relationship would not be able to be established between the two tables. Okay, so cardinality defines the type of table relationship between data sets based on the numerical relationship between one data set's entities and the other. When using GIS software, creating a one-to-one relationship between tables using a common attribute field is called a table join. A table join is one of the most useful and frequently used table relationships operations performed in geospatial analysis. Okay, so before we go to the next slide, really basically the difference between adjoins and relates, I mean, they're kind of the same, but there's like very small differences, and we'll look at it again in the next slide. But adjoins is used for one-to-one relationships or many-to-one relationships between attribute table and an external table. And then a relates is used for a one-to-many relationship or a many-to-many relationship between attribute tables and external tables. So we can see here, when we, let's say, right-click on the county layer, if we want to join the attribute table with an external table, we go to the joins and relates, and then if we were to select that join, we would join the data from an external table to your attribute table based on the value of a field that can be found in both tables. And then again, depending on what you do, you might need to use relate, but most of the time we're going to be, at least for this class, using the joins. Okay, so there are three types of cardinality. We have the one-to-one, many-to-one, and many-to-many. In a one-to-one, each table has only one matching entity, so only one record corresponds to only one other record. So as we can see here in this image, a table join can be established using a field with common attributes or a key. In this case, it is the state name field of the first table, which is the attribute table. And the state fields of the second table. This table join has a one-to-one relationship. One entity in a data set gets matched with one entity in another. So here we have that one-to-one relationship, and again, it's really important to make sure that they all are the same. So we can see here that the name in this the counties layer, or the attribute name, it says Los Angeles, and in this table it says Los Angeles, and so these will not be able to join because they're spelled differently. A lot of the times they can be edited pretty easily, and we could get into that a little bit later.